Okay, we're looking for exact solutions to this trig equation on the interval from 0 to 2 pi. Well, the first thing I'm going to do is isolate the trig function, so I'm going to divide both sides by 3, and I will have tangent of 3x equals square root 3 over 3. Well, I recognize that value as a point on my unit circle, and it's actually rationalized, so I'm going to show you that if we took 1/2 and divided by square root 3 over 2, when we simplified that, we would have 1 over square root 3. If you rationalize that, multiplied top and bottom by square root of 3, you would have square root of 3 over square root of 3 times square root of 3, which is 3. So this will be the point on the unit circle where the sine is 1/2 and the cosine is square root 3 over 2. And so as I think about the unit circle, I want the x value to be square root 3 over 2 and the y value to be 1/2. So that's right here, and that is at pi 6. So one solution, and I'm going to think about this angle for a minute here as theta, it would be when theta equals pi 6. Now we know there's another place that has a positive tangent, and that is over here in quadrant 3. And so another option is if theta equaled 7 pi 6. Now it's not theta, it's 3x, and I want to get several solutions because by the time we divide by that 3, we make those solutions smaller and we can get more solutions on the interval from 0 to 2 pi. And in fact, as we've learned, if there was normally be 2 solutions if we were doing theta, if we have 3 times this, we will get 3 times as many solutions. So there's going to be 6 solutions. If I were to write all solutions, I'd put plus 2 pi k plus 2 pi k. And now what I'm going to do is replace the theta with 3x. So 3x equals pi over 6 plus 2 pi k. And solving for x, I'd have x equal, dividing everything by 3, pi over 18 plus 2 pi thirds k. And you can see what that gives me is it gives me the first angle and then it adds the period. So I'm doing loops around, or I'm doing another cycle with the period, which is 2 pi thirds. And so I can put, if I put k equals 0 in, I get the first solution, which is x equals pi 18ths. I can get 2 more solutions from that by letting k equal 1 and k equal 2. So I'm going to do that. If k was 1, I'd be adding 2 pi thirds, and let's go ahead and make that into 18ths so that we can add that easily. 2 pi thirds is 12 pi 18ths. So adding that to pi 18ths, I would get 13 pi 18ths, which is still on the interval from 0 to 2 pi. Now I'm going to add one more period to that, so I've got 13 pi 18ths, and I'm going to add the 12 pi 18ths, and that's 25 pi 18ths. And again, that is still between 0 and 2 pi. So there are 3 of my solutions. Now I'm going to get the other 3 solutions by taking 3x equals 7 pi 6 plus 2 pi k. And again, solving for x, I would have x equals 7 pi 18ths plus 2 pi thirds k. Kind of squishing it close to that other one. So another solution after these 3, I'm going to put them right here. So another solution is 7 pi 18ths, which we had here. And now we add a period to that. We add 2 pi thirds, but we know that was 12 pi 18ths. So that looks like that's going to be 19 pi 18ths for a 5th solution. And to get our 6th and final solution, we're going to add another period to that. So 19 pi 18ths plus 12 pi 18ths, 31 pi 18ths. And if you doubled 18, you'd have 36. So we're not to 2 pi until we get to 36 pi 18ths. So you can see I have my 6 solutions on the interval from 0 to 2 pi.